This question sets the stage for understanding how to tune the hyperparameters of a support vector machine (SVM) classifier using RandomizedSearchCV in scikit-learn. We're focusing on finding the best combination of hyperparameters, specifically the regularization parameter (C) and the kernel coefficient (gamma), to optimize the model's performance. The use of 5-fold cross-validation and 100 iterations of randomized search are key aspects of the problem. This question sets the stage for understanding how to tune the hyperparameters of a support vector machine (SVM) classifier using RandomizedSearchCV in scikit-learn. We're focusing on finding the best combination of hyperparameters, specifically the regularization parameter (C) and the kernel coefficient (gamma), to optimize the model's performance. The use of 5-fold cross-validation and 100 iterations of randomized search are key aspects of the problem. This statement tests understanding of randomized search-CV. Randomized search-CV samples randomly from the provided hyperparameter space. It does not guarantee finding the absolute best combination. A large hyperparameter space and a limited number of iterations make finding the absolute best combination unlikely, even improbable. Therefore, this statement is false. This statement tests understanding of randomized search-CV. Randomized search-CV samples randomly from the provided hyperparameter space. It does not guarantee finding the absolute best combination. A large hyperparameter space and a limited number of iterations make finding the absolute best combination unlikely, even improbable. Therefore, this statement is false. This statement probes knowledge of the "best score" attribute. After running randomized search-CV, this attribute stores the highest cross-validation score obtained among all the randomly sampled hyperparameter combinations. This score corresponds to the best performing model. So, this is true. This statement probes knowledge of the "best score" attribute. After running randomized search-CV, this attribute stores the highest cross-validation score obtained among all the randomly sampled hyperparameter combinations. This score corresponds to the best performing model. So, this is true. This option assesses whether you know that randomized search-CV explores the hyperparameter space. Randomized search-CV uses random sampling, unlike grid search-CV which tries every possible combination. Therefore, it's not guaranteed to evaluate every possible combination of "C" and "gamma". This statement is false. This option assesses whether you know that randomized search-CV explores the hyperparameter space. Randomized search-CV uses random sampling, unlike grid search-CV which tries every possible combination. Therefore, it's not guaranteed to evaluate every possible combination of "C" and "gamma". This statement is false. This statement tests understanding of "n_iter". "n_iter" defines how many random combinations are tested. Setting "n_iter" to 100 doesn't guarantee a complete search, particularly when the hyperparameter space is large. Only a fraction of the space is explored. Therefore, this statement is false. This statement tests understanding of "n_iter". "n_iter" defines how many random combinations are tested. Setting "n_iter" to 100 doesn't guarantee a complete search, particularly when the hyperparameter space is large. Only a fraction of the space is explored. Therefore, this statement is false. After randomized search-CV samples 100 random combinations of hyperparameters "C" and "gamma" in this case, and evaluates their performance using 5-fold cross-validation. It selects the combination that yielded the highest average cross-validation score. This is the best combination found during the search, not necessarily the absolute best combination possible within the entire hyperparameter space. This attribute of the fitted randomized search-CV object stores the highest average cross-validation score obtained among the 100 Randomly sampled hyperparameter combinations. It provides a measure of the performance of the best model found, reflecting how well it generalizes to unseen data based on the cross-validation process. It's important to note that this score is a result of cross-validation, not just on a single training set. Think of it as the best score among the best-performing model across different folds. This refers to the machine learning algorithm used to find the best combination of hyperparameters for a support vector machine, SVM, classifier. RandomizedSearchCV randomly samples from a provided parameter space, unlike GridSearchCV, which tests every possible combination. Think of it like searching for a treasure. GridSearchCV meticulously checks every single spot, while RandomizedSearchCV randomly digs in a few promising places. This is the set of hyperparameters, and their possible values, that RandomizedSearchCV will explore. In this specific problem, the hyperparameters are C, regularization parameter, and gamma, kernel coefficient, for the SVM. Each hyperparameter can have multiple values, creating a space of possible combinations. These are two crucial hyperparameters for support vector machines. C controls the trade-off between maximizing the margin and minimizing the classification error. A larger C leads to a smaller margin and possibly overfitting. Gamma influences the reach of the kernel. A smaller gamma means the influence of a single training example is limited. RandomizedSearchCV with n_iter equals 100 means it will randomly sample and evaluate 100 different combinations of C and gamma from param_dist . It's not an exhaustive search. Think of it like buying 100 lottery tickets instead of buying every ticket. To estimate how well each randomly chosen combination of hyperparameters performs, 5-fold cross-validation is used. The data is split into 5 parts. The model is trained on 4 parts and tested on the remaining part, repeated 5 times with a different test part each time. The average performance across these 5 folds is used to evaluate the hyperparameter combination. Crucially, RandomizedSearchCV does not evaluate every possible combination of C and gamma. It only evaluates the 100 randomly selected combinations specified by n_iter . After evaluating the 100 random combinations using cross-validation, RandomizedSearchCV identifies the combination that yielded the highest average cross-validation score. This is considered the best combination found through this process. However, this is not necessarily the absolute best combination across all possible hyperparameter settings. This attribute of the fitted RandomizedSearchCV object stores the highest cross-validation score obtained during the random search. This score corresponds to the performance of the best hyperparameter combination found. It provides a good estimate of how well the best performing model is likely to generalize to unseen data. This refers to the core algorithm used for hyperparameter tuning. It's a smarter way to search for the best settings for your support vector machine, SVM. Instead of trying every single combination, which can take forever, it randomly selects combinations to test. Think of it like searching for buried treasure. You wouldn't dig up every inch of the beach, right? You'd use clues and try some promising spots first. RandomizedSearchCV does the same thing for hyperparameters. This is like a menu of options you provide to RandomizedSearchCV. It defines the range of values for the hyperparameters that the algorithm can choose from, values for C and gamma in our SVM case. It specifies what's available. Imagine a menu at a restaurant. Each entry is a possible hyperparameter value. These are the specific hyperparameters for the SVM we're tuning. C controls the model's complexity and how much it penalizes misclassifications. A higher C means more complex models. Gamma influences the reach of the model's influence. The different values of C and gamma are specified within param_dist . This controls how many different combinations of C and gamma values RandomizedSearchCV will try. n_iter equals 100 means 100 random combinations are sampled. It is not an exhaustive search. It's like picking 100 random combinations from a restaurant menu. This is a technique to evaluate the performance of each hyperparameter combination. It divides your data into 5 parts. Each time, it trains the SVM on 4 parts and tests it on the remaining part. It repeats this process 5 times, each time using a different part as the test set. The scores from each of the 5 tests are combined to give a better estimate of performance on unseen data. It's like doing a 5-part test, to get a more reliable result. To assess the performance of each randomly selected hyperparameter combination, a 5-fold cross-validation technique is employed. This means the data is divided into 5 equal parts. Each part takes a turn as the test set, while the remaining 4 parts serve as the training set. The model is trained on the training set and evaluated on the test set. This process is repeated 5 times, and the average performance across these 5 folds provides a robust measure of model generalizability. The _n_iter parameter in _randomizedSearchCV sets the number of random samples from the hyperparameter space to be evaluated. In this scenario, _n_iter equals 100 means that 100 different random combinations of the hyperparameters C and gamma will be chosen and tested. It's important to understand that only a subset of all the possible hyperparameter combinations will be explored. The hyperparameter space refers to the range of possible values for the hyperparameters of the SVM model. In this case, the hyperparameters are C, regularization parameter, and gamma, kernel coefficient. The param_dist variable specifies the possible values for these hyperparameters. _randomizedSearchCV will randomly sample combinations of C and gamma from this space. After evaluating the 100 randomly selected hyperparameter combinations using 5-fold cross-validation, _randomizedSearchCV identifies the combination that yielded the highest average cross-validation score. This is referred to as the best hyperparameter combination. The _best_score attribute of the fitted _randomizedSearchCV object stores the highest average cross-validation score obtained among all the 100 tested combinations. It indicates the performance of the best hyperparameter combination found. This attribute, BESTSCORE, in RANDOMIZEDSEARCHCV, stores the highest cross-validation score achieved during the hyperparameter search. It reflects the performance of the best hyperparameter combination found after evaluating many random combinations. In RANDOMIZEDSEARCHCV, the algorithm randomly samples hyperparameter combinations from the defined grid. PARAMDIST, each sampled combination is evaluated using 5-fold cross-validation. This evaluation measures the model's performance on each combination. After evaluating many random hyperparameter combinations, RANDOMIZEDSEARCHCV identifies the combination that yields the highest cross-validation score. This is then considered the best hyperparameter combination found during the random search. These are hyperparameters for the support vector machine. SVM classifier. C controls the regularization strength, affecting the trade-off between model complexity and training error. Gamma is a kernel coefficient, influencing the model's sensitivity to individual data points. This is a technique used to evaluate the model's performance. The data is split into 5 folds. The model is trained on 4 folds and tested on the remaining fold. This process is repeated 5 times, using a different fold as the test set each time. The average performance across these 5 folds provides a more robust estimate of the model's performance. This is a dictionary-like object that defines the range of values for each hyperparameter. For example, PARAMDIST might specify different possible values for C and gamma, creating a search space for the algorithm. This is a scikit-learn function used to tune hyperparameters. It randomly samples combinations from the hyperparameter grid. PARAMDIST, evaluating each combination through cross-validation. The goal is to find the combination that provides the best performance.